Good morning, dear students. My name is Ferhan Mazher. The subject today we are studying is Cambridge O-Levels Physics 5054. Today we are going to work on a paper 2, and this paper 2 is very special because this paper is a specimen paper for the examination which will be from the 2023. In the syllabus of the Physics 5054, 2 or 3 new topics have been added, especially the Earth and the solar system, stars and the universe. So this specimen paper is very important because this has a sample theory question related to the space physics. So let's start today's paper. I hope you will enjoy this. So Cambridge Assessment International Education, CAIE. This is a specimen paper of the paper 2, which we call the theory paper. And this is for the examination from 2023. The time allowed is 1 hour 45 minutes. And the special thing is that you have to attempt all the questions. In our previous pattern of the paper 2, there was section A and section B. From the section B, you were supposed to attempt 2 questions out of 3 questions. But here in the new pattern, there will be no sections and you have to attempt all the questions. The total marks I have also changed from 75. Previously, the total marks of the paper 2 were 75. Now there are 80 marks. So the first question coming up on your screen, he says, figure 1.1 is the speed time graph for a stone as it falls to the ground. On the figure 1.1, mark a letter X to indicate a point where the rock is moving with a constant speed. A letter Y to indicate a point where the rock is decelerating. So it's a speed time graph. So in this portion, the rock is falling at a constant speed. So here I will write X. And here the rock is decelerating. So here I will write Y. So let me show you. So you can see I have X will be here, the Y will be here. So this is the marking scheme. Our answers are right. Okay, the next question. At the time t equals to 0, the acceleration of the stone is equals to the acceleration of the free fall. Give the name of the force accelerating the stone at t equals to 0. When the time is 0, the only force acting on the stone is its weight, or you can say the gravitational attraction of the earth. So I can say weight. So you can see I've written weight. You can say weight or you can say gravity. Okay, so next thing, B part. Question number 1, B part. The weight of the stone is 4 Newton. As the stone falls, the force F of air resistance acting on the rock changes. State the value of the F when at the time t equals 0. When the time is 0, because the stone has not yet started moving, so the air resistance acting on the stone will be 0. So here you will write 0. Then it says state the value of the F at the time t equals to 10. When the time is 10, the stone is moving with the constant speed. That means that the air resistance and the weight, they are equal to each other. The weight of the stone is 4 Newton. So the air resistance at time t equals to 10 seconds will be also equals to 4 Newton. So let's check 0 and 4 Newton. So our answers are right. 0 and 4 Newton. Okay, then he says in the third part, he says suggest why the F changes between t equals to 0 and t equals to 10.0 second. You see, from 0 to 10 seconds, the stone is accelerating. The speed of the stone is increasing. As the speed of the stone will increase, the air resistance acting on the stone, that will also increase. So let me show you my written answer, then we will check from the marking scheme. As the stone falls, it accelerates. As speed increases, the air resistance acting on the stone also increases. So this is my answer. So let's have a look at the marking scheme. It says due to increase in the speed or more air particles, molecules hitting the rock. Okay. So our answer is right. C, first part. Using the figure 1.1, determine the acceleration of the rock at t equals to 4 seconds. State the unit of your answer. You will need to draw a tangent to the graph in the figure 1.1 and show your working. So we have to calculate the acceleration when the time is 4 seconds. And if you look at the graph, at 4 seconds, the speed time graph is a curve. And if you want to find out its gradient, at 4 seconds, you will have to draw a tangent at 4. And then I will take 2 points on that tangent, and by using those 2 points, I will find the gradient of the tangent, and whatever will be the gradient of the tangent, that will be the gradient of the curve at 4 seconds. And that the gradient of the speed time graph is equals to, acceleration. So you can see at 4, I have drawn a tangent. This red line is the tangent. And I will take 2 points on this red line. And here we go. So I've taken 0, 10 and 4, 42. And I will apply the formula of the gradient, that is y2 minus y1 divided by x2 minus x1. So it will be 42 minus 10 divided by 6 minus 0. That will be 32 divided by 6. And that will be 5.33 meter per second square. 5.33 meter per second square. So the answer says a tangent drawn at the 4 second, and the acceleration value will be from 5.0 to 5.8. Our answer is 5.33. So that is right. Unit will be meter per second square. So our answer is right. Okay. So the next thing they are asking is C, question number 1C, and its second part. He says the mass of the stone is 408 grams. Determine the force F of the air resistance acting on the rock at the time t equals to 4 seconds. Show your working. Okay. So we can find the mass is given 408 gram, and the acceleration we know at the 4, that is 5.33 meter per second. And the F is equals to ma, and the F will be equals to 408 divided by 1000. Why I'm dividing with 1000? Because in this formula, when you use the mass, its unit must be in kg. The mass is given in grams, so I will divide it with 1000 to convert it into kg. So 408 divided by 1000 multiply 5.33, that will give you 2.175, which is approximately 2.2 Newton. So the force is approximately 2.2 Newton. So you can see here it's from 2 to 2.4 Newton. So our answer is in this range. So my dear students, we are done with the question number 1. I hope you understand. Okay, so we are on the next question, and that is question number 2. It says figure 2.1 shows a black car going up a hill on a sunny day. State one way in which the car is gaining thermal energy. So there are many ways. The car is of the black color. So the black color is a very good absorber of the infrared radiation. So it will be absorbing heat from the sun. Another way is the fuel is being in the engine of the car. The fuel is burning. So when the fuel is burnt, thermal energy is produced. So by the burning of the fuel, the car is gaining the thermal energy. So you have to give one way, one method by how you have to explain how the car is gaining the thermal energy. So combustion of the fuel in the engine produces heat energy. So that is causing the car to gain So the answer is heat gained from the burning the fuel, combustion or friction between the moving parts with air, roads, or from radiation of the sun. So I hope you can write a good answer. We only have to write one reason. Okay, so question number 2A, second part, one way in which the car is losing thermal energy. So the car is losing thermal energy. One way I can tell you is that the car has a radiator, and that radiator is used to take the heat from the engine of the car and it dissipate it into the air. Another way is the exhaust exhaust from the exhaust, hot gases are coming out. That is also a way of losing the heat which is in the car. Radiator loses heat into the to the surrounding. Okay, so heat lost to air surrounding or by convection currents or exhaust, hot gases, fumes, or from exhaust or heat emitted by hot car or by radiation. Okay, so the next question is the car accelerates up the hill. In addition to an increase in thermal energy, there are other energy transfers taking place. Describe the other energy. Because the car is accelerating, it's going uphill. So when you are going uphill and obviously the fuel is burning, so the biggest change happening is that the fuel of the car is burning. So when the combustion of the fuel takes place, its chemical potential energy is decreasing because the fuel is burning. So gradually the fuel is decreasing. It means that the chemical potential energy is decreasing. And because the car is going, it's accelerating, so that it means that it is gaining kinetic energy. And another important thing is that the car is going up the hill, so that means that the car is gaining gravitational potential energy. Okay, so I have tried to write the answer. Petrol is used, so or in the stead of using the word petrol, you can use the word fuel. Fuel is used, so chemical potential energy is decreasing. Car is going uphill, so the gravitational potential energy is increasing. Car is accelerating due to increase in the speed. Kinetic energy of the car is increasing. That's my answer. So let's check. At the start, store of chemical potential energy decreases, gravitational potential energy of car increases, kinetic energy of the car is increasing. So I think our answer is right. Okay, so question number 2, it's C part. He says at one point in the motion, the kinetic energy of the car is 90 kilojoules. The mass of the car is 800 kilojoule. Calculate the speed of the car. The kinetic energy is given, that's 90 kilojoules, which means 90,000 joules. And the mass of the car is 800 kg. The speed of the car is the question. You know the formula for the kinetic energy is 1 by 2 mv square. So we know the kinetic energy value, we know the mass, so very easily we can find the speed. The kinetic energy, so you see the kinetic energy is given 90 kilojoules, which means 90,000 joules. The mass is 800 kg of the car, and the velocity is question. The kinetic energy is equals to 1 by 2 mv square. So 90,000 is equals to 1 by 2 into 800 into v square. So the v square will be equals to 90,000 multiplied 2 divided by 800, which will be 225. Take square root on both the sides. So the v will be equals to the square root of the 225, and that will be 15. So the velocity of the car or the speed of the car will be 15 meter per second. 15 meter per second. So you can see 15 meter per second is the answer. So our answer is right. Question number 3, a passenger in an aircraft seals some air inside a plastic bag. So it's a plastic bag which has air in it and they have sealed it. Explain how the particles of the air in the bag exert a pressure on the inside of the bag. It's a 2 marks question. So you see the molecules or the particles of the air, they are randomly moving. So during their random motion, what happens? The particles of the air, they collide with the walls of the plastic bag. When they collide with the walls of the plastic bag, they exert force on the walls of the plastic bag. So that force per unit area of the plastic bag will be the pressure of the gas inside the sealed plastic bag. So my written answer is particles of the air move randomly in the bag. Particles collide with walls of the bag. They exert force on the walls of the bag during their collision. Force exerted per unit area of the bag is pressure of the air in the bag. That's my answer. Question number 3, it's A part. The particles hit inside the wall. The particles, they create a force and a reference to area. So I think our answer is perfect. Okay. So the B part, question number 3, B part. When the bag is closed, the pressure of the air inside the aircraft is 80 kilopascal and the bag contains 500 cubic centimeter of air. When the aircraft is on the ground, the pressure of the air inside the aircraft is 100 kilopascal. Calculate the volume of the air inside the bag when the aircraft is on the ground. The relationship between the pressure and the volume, very famous formula, P1 V1 equals to P2 V2. So I can find out very easily the volume of the air. So P1 V1 equals to P2 V2, 800 kilopascal multiply 500 equals to 100 multiply V2. V2 is the question. So the V2 will be 80 multiply 500 divided by 100. So the V2 will be 400 centimeter cube. Important thing is this is also kilopascal. This is also kilopascal. So the kilo will be cancelled. 400 centimeter cube. 400 centimeter cube is the right answer, sir. B, question number 3, B, and its second part, he says state one assumption that you made in your calculation. So when we use the formula P1 V1 is equals to P2 V2, this gas law can be only used if the temperature of the gas do not change. So our assumption is that the temperature of the air is constant. So our assumption is that the temperature of the air is constant. Okay, now we are going to the next part. Here we have question number, this is question number 3, it's C part. The point plotted on the graph in the figure 3.2 show the initial pressure and volume of the air inside the bag. Sketch a line on the figure 3.2 to show how the volume of the air changes as the pressure changes. Okay, so we know at 100 the pressure is, the volume is 400. Put a dot here, and I will join them with a curve like this. Okay, I will join them with a curve like this, the curve which shows the inversely proportional relationship. So let me show you. I have drawn this. Okay, so you can see this is the and I have drawn this curve with the mouse, so it's not that smooth, but you are supposed to draw a smooth curve. This curve is that curve which shows a relationship between volume and pressure, and the relationship is inversely proportional. So the curve will be something like this. So you can check the marking scheme also. Okay, so we are going to the next question, and that is question number 4. He says one type of renewable energy source is shown in the figure 4.1. So they are pumping down cold water into the rocks, which are hot, and then hot water and the steam from the other pipe is coming out. Hot water and steam is coming out. State the name of the renewable energy source shown in the figure 4.1. This energy source is called geothermal energy. The geothermal energy. This is called geothermal. This is called geothermal. Geothermal energy. Geothermal energy is the answer, sir. Okay. Then the question is, in question number 4, it's B part. He says, 100 kg of cold water at a temperature of 20 degrees centigrade is pumped down to the hot rocks. The water returns partly as steam and partly as hot water. The steam and the hot water are both at a temperature of 100 degrees centigrade. The specific heat capacity of the water is 4200 joules per kg per degree centigrade. Calculate the energy needed to heat 100 kg of water from 20 to 100 degrees centigrade. So they are talking about a change in temperature, and the change in temperature is from 20 to 100. The mass of the water whose temperature is to be changed is 1000 kg. 1000 kg, sorry. And its specific heat capacity is also given. When the temperature changes, the formula for the heat is equals to mc delta theta. mc delta theta. So heat is equals to mc delta theta, where m is the mass in kg, c is the specific heat capacity, and delta theta is the change in temperature. So it will be 1000 multiply 4200 multiply, in the bracket I will write 100 minus 20. That's the change in temperature. So it will be 1000 multiply 4200 multiply 80. So it will be 3.36 expo 8 joules. 3.36 expo 8 joule. So 3.36, which is 3.4, approximately 3.4, and expo 8 joules. Our answer is right. Okay, then the question is plain. Why more energy is transferred when 1 kg of the steam cools to 20 degrees than when 1 kg of the hot water cools to 20 degrees centigrade? You see, in the case of the steam, first of all, the steam will convert into into water. So first of all, the condensation of the steam will take place. Means the steam will convert into liquid water. And then the temperature of the steam, that liquid water, will drop to 20. So in the case of the steam, there will be more energy involved because the steam has to change the state. So the latent heat of fusion will be given out. And when the latent heat of the fusion is given out, the steam converts into liquid water, and that liquid water obviously have stronger intermolecular forces. They are created, and it has strong intermolecular bonds, so those bonds are formed. So what will happen? The potential energy, that will decrease, and that's why when the temperature of the water decreases from 100 to 20 degrees centigrade, or from any temperature to 20 degrees centigrade, it do not involve that much energy as you do the same thing with the steam, because in the water no latent heat will be needed. So that's why when you drop the temperature of the steam to 20 degrees centigrade, more energy is transferred. So I hope you understand that the basic reason is the latent heat given out, and the decrease in the potential energy. So that's why the more energy will be transferred in the case of the steam as compared to the liquid water. When the steam temperature decreases to 20 degrees centigrade, steam converts into liquid, so latent heat is given out. Molecules of the water come close to each other, their kinetic energy decreases, intermolecular. So after they are converted into the water, the kinetic energy decreases, and decreases, intermolecular bonds are formed. This decreases the potential energy. In case of liquid, only the kinetic energy and the potential energy decreases. So I hope you can write this answer, or you can write a better answer. Have a look at the marking scheme. It says steam condenses or steam changes from gas to liquid, and latent heat given out, and particles come closer together, or potential energy of the particle decreases, or bonds being made. Okay, so hopefully you can write a better answer. Question number, now we are going to the next question, and that is question number 5. He says the figure 5.1 shows light in air incident on the side of a rectangular glass block at an angle of 60 degrees. Okay, this angle of incidence is 60 degrees. The refractive index of the glass is 1.6. The light travels in the glass and is incident on the side XY at P. Underline all the terms that describe a wave of the light. The wave of the light is a transverse wave and it's an electromagnetic wave. So I will underline the electromagnetic and I will underline the transverse wave. Okay. So electromagnetic and transverse. So you can see electromagnetic and transverse. Then he says at the point where the light enters the glass, the angle of the refraction is R. Calculate the angle R. So I have to calculate this angle R. I know the angle of incidence and I also know the refractive index, which is represented with the small n. You know the n is equals to sine I divided by sine R. So from there, I can find out the value of the R. So I will write n is equal to 1.6. Angle of incidence is 60. Angle of refraction is question. The famous formula, Snell's law, we call it, n is equals to sine I by sine R. So 1.6 is equals to sine of 60 and divided by sine of R. So sine of R will be equals to sine of 60 divided by 1.6. So the R will be sine inverse of sine 60 divided by 1.6, that gives you 0.541. So shift sine 0.541 equals to, and that will be 32.8 degrees. So the angle of refraction will be approximately 33 degrees. So question number 5, B part, 33 degree is the right answer, sir. So I hope you understand this. Then their question is calculate the critical angle C of the light traveling in the block. That is question number 5. It's C part. You know, if you know the refractive index, you can find out the critical angle. N is equals to 1 by sine C. N is equals to 1 by sine C. So 1.6 is equals to 1 by sine C. So sine C will be equals to 1 divided by 1.6. So the sine C will be equals to sine inverse of 1 divided by 1.6, bracket close, and you will get 38.7, which is approximately 39 degree. So the critical angle is 39 degrees. So our answer is right. He says calculate, okay, at the P, the angle theta given between the ray and the normal is given by theta is equals to 90 minus R. So state and explain what happens to the light when it is incident on the side XY. So basically they are talking about here, what will happen here. This theta is equals to 90 minus R. So I can find the value of this theta. I know the value of the R. So then I will decide what will happen here. So you see, first of all, I will do this calculation. So theta is equals to 90 minus R. So theta is equals to 90 minus 33. So theta will be 57 degrees. So the angle of the incidence theta is more than the critical angle in the dense medium. So the process of the total internal reflection will take place. So the process of the total internal reflection will take place at the point P, and the light will be reflected back into the glass. So you can see the marking scheme. So our answers are right, sir. Okay. So we are done with the question 5. Now we are going to the question number 6. He says, a 4.5 volt battery is connected in a circuit with an ammeter, a light dependent resistor, and a 1800 ohm fixed resistor. Figure 6.1 is the circuit diagram. Okay. The light incident on the LDR causes its resistance to be 9,000 ohm. Okay. So this is fixed resistor. This is, LDR. Its resistance right now is 9,000 ohm. Their question is calculate a first part. He says calculate the total resistance of the circuit. So we can find out that this is a 2 marks question. Total resistance of the circuit. These two are this is 1800, this is 9,000. They are parallel to each other. So when the resistors, they are connected in parallel to each other, you can find their equivalent resistance. The formula is 1 by R equivalent is equals to 1 by R1 plus 1 by R2. So 1 by R equivalent will be equals to 1 by 1800 plus 1 by 900. So in your calculator, you will do this calculation. 1 divided 1800 plus 1 divided 9000. So it will be 1 by 1500. So 1 by R equivalent is equals to 1 by 1500 cross multiply. So you will get R equivalent is equals to 1500 ohm. So the two resistors which are in parallel to each other, their combined resistance will be 1500 ohm. So you can see our answer is right. They say the reading on the ammeter. So I know the resistance here and I know the EMF. So I want to find out how much current is coming from the battery. The formula is very simple. The current coming from the battery, that will be equals to the EMF divided by the R equivalent. The EMF is 4.5 and the R equivalent is 1500. So it will be 4.5 divided by 1500, that will be 0.003 ampere. 0.003 ampere is the right answer, sir. Okay, so we are going to the next part. He says a very bright lamp is switched on and the intensity of the light incident on the LDR increases. State and explain what happens to the current in the LDR. You see, the current will increase, and the reason is when you increase the brightness on the LDR, its resistance will decrease. The voltage drop will not change across it because it's connected parallel to the 1800 ohm, and that is connected parallel to the battery. So the voltage drop on the LDR is still that much, and due to the light, the resistance that will decrease. So now, according to the Ohm's law, the current will increase. So because you have increased the brightness, so due to that, the resistance has decreased. Voltage drop is still the same, so the current will increase. That's the explanation. And in the second part, he says, state and explain what happens to the current in the 1800 ohm resistance. This is very important. Try to understand. You see, 1800 ohm is connected parallel to the battery, plus it is connected parallel to the LDR. Because it's a fixed resistor, so its resistance will not change. And because it is connected parallel to the battery, so the voltage drop on it will remain still the 4.5 volt. It will not change. So the voltage drop on the fixed resistor has not changed. Its resistance has not changed. So the current passing through the resistor will also not change. So what happens to the current? The current remains the same. And the explanation is because the voltage drop across the fixed resistor will still be same, whatever it was before. And that will be equal to the voltage drop of the battery. And the resistance obviously has not changed. It's a fixed resistor. So the current flowing through it will also not change. Let me show you my answers. So B, first part, question number 6B, first part, current will increase as the brightness of the light increases, the resistance of the LDR decreases. And for the B, second part, current remains the same and resistance and the voltage drop of the fixed resistor remains constant. They have not changed. That's why the current has not changed. So question number 6 is both parts are showing up here in the marking scheme, and I have already checked them. So you can have a good look on them. Okay. You can pause the video when you want to see that marking scheme. Okay. So we are going to the next question. Next question on your screen is question number 7. He says, figure 7.1 shows a horizontal current carrying wire PQ in the gap between the poles of a permanent magnet. Okay. So here we have a current carrying coil. The current is going in this direction. The magnetic field is going upward. North is down at the bottom and the south is above. So the magnetic field is in the upward direction. Their question is, there is a magnetic field in the gap between the North Pole and the South Pole. The current in the PQ is from left to right. Okay. Describe the effect of the magnetic field on the PQ. You see what will happen because you can apply the left-hand rule. You can apply the left-hand rule. You can see this is my left hand. And this is my left hand, this is my thumb, this is my index finger, and this is my middle finger. This is force, this is magnetic field, and this is current. Okay, so stretch your fingers of your right hand, sorry, your left hand, in such a way they are mutually perpendicular to each other. Okay, so the magnetic field is going upward, the current is going in this way, my thumb is pointing out of the page. So what will happen? The PQ is a current carrying coil which is placed perpendicular to the magnetic field. So by using the left hand rule, I can tell due to the motor effect, the PQ will move out of the page. Okay, so let's see. PQ is a current carrying conductor placed perpendicular to the magnetic field. By using the left hand rule, we can say that the PQ will move out of the page because it will experience a force whose direction will be out of the page, so it will move out of the page. So there's a force on the PQ wire, P wire moves, force movement out of the page towards observer, ignores upwards. Okay, so our answer is right, sir. Then the question is question number 7. It's A, and its second part. State the effect on the PQ of increasing the strength of the magnetic field in the gap. 1 mark question. If you will increase the magnetic field here, the force experienced by the PQ current carrying conductor will be larger. So it will experience a larger force. That's why the PQ will move faster out of the page. PQ will experience a larger force and it will move out of page at faster rate. So force, speed, acceleration greater. Okay, so our answer is right, sir. Then question number 7, it's B part. He says, figure 7.2 shows part of a torch. The torch does not contain a battery. Okay, the torch does not contain a battery. The torch is shaken and this causes the magnet to move backward and forward through the coil. Explain why an electromotive force is induced across the coil when the magnet moves. You see, when this magnet will move relative to the coil, the magnetic flux of this magnet passing through the coil, that will change. And due to this changing magnetic flux passing through the coil, EMF will be induced in the coil. This is called electromagnetic induction. So, where's the answer? Okay. When the magnet moves relative to coil, magnetic flux passing through the coil changes. Due to changing magnetic flux, EMF is induced in the coil. So that's the B first part. Magnetic field flux mentioned, change in the field of flux in the coil or field lines cut, coil or wire. So our answer is right, sir. Okay. Then we have, B. Second part. State one way to increase the EMF induced. You see, in this system, if you want to increase the EMF produced in the coil, so there are some methods. First method is use a stronger magnet. Second method can be move the magnet in and out faster. And third method can be increase the number of the turns per unit length of the coil. There can be many methods. You only have to give one. So move the magnet faster. Okay. So they say magnetic more turns or stronger magnet or move magnet faster. So our answer is right, sir. Third part is as the magnet moves into the coil, the induced EMF produces a current in the coil. Explain how this opposes the motion of the magnet. Okay, you see, by the motion of the magnet, the EMF is induced in the coil. And so when the EMF is induced, due to that induced EMF, the coil becomes electromagnet. And the direction of that induced current is always such that electromagnet which is formed on the coil its polarity will be in that way that it will oppose the motion of that permanent magnet. For example, the north of the permanent magnet, for example, the north of this permanent magnet is approaching the right side of the coil. For example, this is a scenario. So for example, the north pole of this permanent magnet is going near the right side of the coil. So due to that movement of the magnet, the EMF will be induced in the coil, and the direction of the EMF induced in the coil will be such that due to this EMF, the electromagnet which will be formed on the coil, it will make its north pole on the right side of the coil, so that the north pole can oppose the approaching north pole of the permanent magnet. So this is called the Lenz's law, and so the EMF induced, its direction will be always such that it will try to oppose the cause which is producing that EMF. That is called the Lenz's law, and we have a question on it right now. Due to induced current, magnetic field is created in the coil. The polarity of the magnet induced in coil always opposes the motion of permanent magnet. If north pole of the permanent magnet is approaching the right side of the coil, the right side of the coil will become north to oppose the approaching permanent magnet's north pole. I hope you understand. Magnetic field, sorry. This is done. Current in the coil produces magnetic field or poles north pole created at right hand of the coil or repels magnet field in the opposite direction. Hopefully you understand. The answer is right in front of you. Okay, we are going to the next question, and the next question coming up on your screen is question number 8. He says, figure 8.1 shows a circuit containing 230 volt AC supply connected to a television and 2 lamps. In normal operation, both switches are closed. The power supply to each lamp is 40 watt, and the power supply to the television is 120 watt. Calculate in normal operation the total number of kilowatt hour of energy supplied to circuit in 1 hour. Okay, so the total power of this circuit, these powers will be added up, 40 plus 40 plus 120. So that will be 200 watts. And you know the energy can be calculated. The formula is energy is equal to power multiplied time. The power must be taken in kilowatts, and the time should be taken in hours. So 200 watt is the total power. So divided with 1000, and the time is 1 hour. So you can see 200 divided by 1000 multiply 1. So it will be 0.2 kilowatt hour. 0.2 kilowatt hour. So that is the energy. 0.2 kilowatt hour is the right answer, sir. This is how this is solved. Okay. He says the current in each lamp. So I know because you see this, and this, they three are parallel to this power supply. So the voltage drop here is 230 volt. The voltage drop here is 230 volt. The voltage drop here is 230 volt. Okay. So their question is the current in the each lamp. I know the power, that is 40 watt in the lamp. I know the voltage, that is 230 volt. I can find out the current in that lamp. Power is equals to IV. So I is equals to power divided by the voltage. The power of each lamp is 40 watt, and the voltage drop, because they all are parallel to the battery or the power supply, that is 230 volt. So 40 watt divided by 230 volt, and that will be 0.174 ampere, which is 0.17 ampere in two significant figures. So question number 8A, second part, 0.17 ampere is the right answer, sir. Hopefully you understand what I am saying. Okay, then the question is explain why the switches are placed in the live wire and not in the neutral wire. You see, the switch is always connected in the live wire. The reason is that when the switch is in the live wire and you open the switch, your appliance will switch off, and the supply of the live current to your appliance will be cut off. Your appliance will be isolated from the high voltage live current. If the switch is connected in the neutral wire, when you will open the switch, the appliance will be off, it will stop working, the path of the current will be broken, so the appliance will not work, but the appliance will be still connected with the live wire. So your appliance will be receiving, or it's in connection and it's getting high voltage live current. So it can be very dangerous. You might think that the appliance is off, but it still has live current. So it can cause electrocution. So I hope you understand what I'm saying. So let me show you my written answer. Okay. Switches are placed in live wire. When switch is opened, appliance is isolated from high voltage current. If it is, the switch is installed in the neutral wire, on opening the switch, appliance stop working, but it remains connected to high voltage current, which can cause an electric shock if you touch or you open that appliance. That can be very dangerous. You think that the appliance is off, but it's not. To stop the rest of the circuit, lamps, television being live, having high voltage, or to stop the shock, or when the switch is off. Okay, so our answer is right. Okay, so we are going to the next part. That is the question number 8, and it's C party state. State one advantage of connecting two lamps in parallel in this circuit. You see, in our chapter, we have studied that when you connect the lamps in parallel to each other, the voltage drop across them remains the same. So their brightness remains the same. If you connect them in series, the voltage they each get is decreases, and their brightness is not same. Another very important advantage of connecting the lamps in parallel is that if one of them will be fused or stop working, or something happen with one lamp, the other lamp will still continue giving out the light. So you just have to write one benefit. So when the lamps are parallel, they get they get same amount of the voltage, so their brightness remains same. If one fuses, the other lamp continues to work. I have written two benefits. You only have to write one. If one lamp fails, the others will still work. Okay, so that was the question number 8. I hope you have understood. I have tried my best to explain you the concepts. Okay, so now we are going to the next question, and it says the figure 9.1 shows the main parts of a nuclear reactor. Okay, so this is a nuclear reactor. Here you can see this is the fuel rods. Fuel rods are those uranium rods, and then this is moderator. Here we have moderator. Okay, so then we have here, these are the control rods. If the control rods can absorb the neutrons, and so the coolant comes from here, and then from here it takes away the heat. Okay, so that's a basic structure of a nuclear reactor. Shows the main parts of a nuclear reactor. The question is the fuel rod contains uranium-235, which can undergo nuclear fission. Describe the process of nuclear fission that occurs in the fuel rod. Your description should include the role of neutrons in the process. Okay, so what we do, we take a neutron and we accelerate it, and then we bombard the atom, the nucleus of the uranium-235. So when the neutron hits the nucleus of the uranium-235, the nucleus breaks. it splits into two smaller nuclei, and we call them daughter nuclei. One of them is the barium, the other one is krypton. And when this happens, when the uranium nucleus breaks and two smaller new elements are formed, their nucleus are formed. With this, three neutrons are also given out, and a lot of energy is also given out. So those three neutrons, they can hit three more uranium nucleus, and this process continues. Okay, so a neutron will hit the nucleus of a uranium atom, and that nucleus will break. It will split into two smaller nucleus, and with this, three neutrons is produced, a lot of energy is produced, and those three neutrons which are produced, they can do the fission of three more uranium nucleus. And from those 27, from those 9 neutrons will be produced, and this process goes on. Okay, so neutrons are bombarded on the uranium atom. When a neutron hits a uranium nucleus splits into two smaller daughter nucleus. In this process, 3 neutrons are given out. This process releases large amount of energy. That's my answer. So let's check what the marking scheme says. Okay, the marking scheme says the neutron absorbed by a nucleus of uranium. Nucleus splits into two smaller or daughter nuclei, releasing energy, and emits more neutrons. So our answer is right. This is the answer. Question number 9A part. Okay, then their question is question number 9B part. He says, explain what happens to a control as state what happens as a controlled rod is removed out of the reactor core. So you see, if you will pull the control rod upward or out, so the uranium rods will be exposed to the neutrons. So more and more neutrons will be able to hit the uranium nucleus, and the fission process will become faster, and more energy will be given out. So when when the control rods are removed from the reactor core, more neutrons are able to split uranium atom, more fission takes place, more energy is given out. The process will start happening fast because you have exposed uranium to the neutrons. Okay, he says on average, where is that? He says less or fewer neutrons absorbed by the control rods, or more neutrons to cause fusion, the fusion will increase, more energy produced, or higher temperature or more fission reaction occurs. I hope our answer is right. You can write a better answer always. This is just an idea that how an answer should be written. You can, I believe that my student can write a better answer because he has the time to read more books, and he's studying from me, he's studying from his teacher, he's studying from another tutor, and he's studying more IGCSE book, he's studying the physics matter. So student can always write a better answer. Okay, just once he gets the right idea, then he can write a better answer. Okay, C part, question number 9, C part. The nuclear reactor releases energy at a steady rate. By referring to the neutron, describe what is happening to achieve this steady rate. Okay, so what we do, we use, it's an idea which normally, because we do not study atomic physics, we are on a very naive in this physics. So the neutrons, whenever one fission happens, 3 neutrons are produced. So we use moderator, and what in the nuclear reactor we use a liquid which is moderator. So what that moderator do, that moderator slows down those neutrons. So when you slow down those neutrons, then there's the probability that those neutrons will hit a uranium nucleus, that increases when they slow down. So the probability that they will hit a uranium atom and they will do the fission, that increases when the moderator slows them down. So by using a moderator, we make sure that the neutrons are under control, we slow them down, and then the probability of them hitting a uranium nucleus, so that increases. Ooh. Only one of the neutrons produced in a fission reaction is allowed to hit atom of uranium. Other two neutrons produced are absorbed by the control rods. Okay, so sorry, I told you the explain the purpose of the moderator in the nuclear reactor. I told you the process, the function of the moderator also. You see, the three neutrons are produced, and we let only one of them do the fission. The rest of them, they are stopped or slowed down. And why we do that? Because we want to control that system. If you do not control, if you let all the neutrons go free and do the fission, that reaction will get out of your control. Okay, because it's a chain reaction, it does not require any fuel or anything. Once you started it, it started. So then it do not require any kind of energy from external energy. It goes on its own. So the neutrons which are produced, you need to slow them down, you need to control them, so that the control rods will absorb them. In this answer, the control rods will control them, they will absorb them, so you can control it. Only one of the neutrons, okay, so I have written this answer, so let me show you. On average, only one of the neutrons produced by each fission goes on to cause other nucleus to fission. Neutrons absorbed by the control rods. Okay. And what is the function of the moderator? Moderator is a liquid which is in that reactor. It slows down the neutrons. And I told you that when the neutrons are slow, then their chance of hitting an uranium atom and doing the fission increases. The probability increases. It's a little complicated thing. Okay. A moderator is a material used in a nuclear reactor to slow down the neutrons produced from fission. By slowing the neutron down, the probability of a neutron interacting with uranium nuclei is greatly increased, thereby maintaining the chain reaction. So, okay. So it slowed neutrons down so that they have a larger chance of being absorbed by another uranium nucleus. Okay. So I mixed that answers. His answer is different. His answer is a little different. It seems to be same, but I hope it's clear to you. I just mixed them up. So I can show you the answer, written answers first. So you see, this is the answer 9C part. This is 9D part. Don't mix them up. Okay, my dear students. So now we are on question number 10, and the question number 10 is about, this is from the topic, the new topic which is added into the Cambridge Physics 5054. The name of the topic is space physics, and we do not have the questions on this topic in all our past papers. So that is the first theory question released from the Cambridge. The sun is a star in a stable part of its life cycle. So the stars, they have life cycles, and the sun is right now in the stable part of its life cycle. Okay. Use idea about forces, explain how the sun remains stable in this part of its life cycle. Okay. So the sun has enormous amount of gravity, so which is trying to shrink it, and due to the fission, high temperature, pressure, that energy is in outward direction. So that is the balance between these forces, and the sun is in the stable condition. And let me show you. I just in a in a stable star like our sun is also stable right now. In a stable star such as our sun, the very strong forces of gravity pulling it inwards are balanced by the opposing forces trying to make it expand due to its extremely high temperature. This thermal pressure arises from the kinetic energy of the nuclei in the core. When forces are balanced, the star is in a stable state. The star is in a stable state. So let me show you the marking scheme. And it's trying to collapse due to the gravity balanced by outward forces due to high temperature and the pressure of the light. Okay. In a stable star such as our sun, the very strong forces of gravity pulling it inward are balanced by the opposing forces trying to make it expand due to its yeah, I can tell you the answer. In a stable star such as our sun, the very strong forces of gravity pulling it inwards are balanced by the opposing forces trying to make it expand due to its extremely high temperature. This thermal pressure arises from the kinetic energy of the nuclei in the core. When the forces are balanced, the star is in a stable state, which may last for up to 10 billion years, during which time most of the hydrogen in the core is converted to helium. So I hope you understand. Uh, I I have recommended my students, the students who are under my supervision in my school, to watch maximum documentaries released by the National Geography on the solar system, on the stars, on the planets. Watch them again and again, watch them. Okay, so this question is done. Okay, the next question is describe what happens to the stars of similar mass to the sun at the end of the stable part of their life. You see, at the end of the stable part of their life, the fuel on which they are means hot. The fuel on which they are the fuel is the hydrogen and hydrogen, they are fusing together, and that's producing enormous amount of temperature and heat, and that fuel will be used. And once that will happen, the star, it will convert into a red red giant, and joint, and then it will convert into a dwarf star. Then it will convert into a dwarf, white dwarf, and then into black dwarf. Okay, so let me show you. I have that answer, and it's a pretty long, lengthy question. So this is a diagram which shows what happens. So if the star is stable, and that depends what will happen when its fuel is used up, the stable state is cycle is finished, it will become a red giant. And once red giant, then the two things can happen. One is that if the mass of the star is very high mass of the star, our sun is in the low mass star. Okay, so our sun, what will happen with our sun? The question is, what will happen with our sun? That will convert into the planetary nebula with white dwarf at the center. Then it will convert into the white dwarf and then into black dwarf. Okay, so remember this diagram, don't forget it, because the answer which I'm going to read for you is on this diagram. And this is our sun. This is the future of our sun. Okay, and this is the future for the other stars which are way bigger than our sun. Okay, so let me read the answer. It's a bit of the answer. Okay, when the stars When the star starts to run out of hydrogen, a fuel for nuclear reactions, it becomes unstable. There is less energy being produced by nuclear fusion to sustain the outward thermal pressure, and the core collapses inward. Under gravitational attraction, gravitational potential energy is transferred to kinetic energy so that the core becomes hotter. There is a fast burn up of the remaining hydrogen envelope in contrast to the core, and a huge expansion and subsequent cooling of the surface gases. The star turns into a red giant. As the core heats up, its temperature becomes high enough for the nuclear fusion of helium into carbon to occur. Star will convert into white dwarf, and at the end black dwarf. Ooh, it's a big answer. Okay. So, but we can further reduce this answer, but this is because I wrote that the whole thing, so that you can have an idea that what we are talking about. So you can see here, runs out of the hydrogen or starts to fuse other elements. Okay, expands to become a red giant, and shrink cools to become a white dwarf planet star. Sorry. So they want only these three things, but I have written the whole article so you can understand, and I have written this answer from the IGCSE physics book. Okay, you can find this answer there, because this is the purely new topic and my students, they have not yet studied this chapter, so we want them, so we are giving the article as well. Okay. Okay, the next question is, the orbital speed of the earth the orbital speed of the sun is 30 kilometer per second. Use this value to calculate the distance of the earth from the sun. The distance of the earth from the sun is the radius of the orbit of the earth around the sun. So, and you know the orbital speed, that is the circumference of that orbit divided by the time. The orbital speed is the circumference of that orbit in which the earth rotates around the sun divided by the time. So the orbital speed is given, that's 30 kilometer per second. The orbit is 2 pi r. R is the radius, which is the question here. And the time is in seconds. We have to take the time in seconds, because in the orbital speed, the time is given in seconds. So in how much time the earth completes one orbit around the the sun, that is 365 days. So in one day you have 24 hours, and in 1 hour you have 3600 seconds. So very easily we can find the radius of this, and here we go. So the speed is 30 kilometer per second. That is orbital speed. Okay. So orbital speed is circumference of that orbit divided by the time taken for the Earth to complete that orbit. So the orbit circumference will be 2 pi r divided by the time. So the orbital speed is 30 kilometer per second. 2 pi r is the question. And the time is 365 multiplied 24 multiplied 3600. So the R will be equals to 30 multiply 365 multiply 24 multiply 3600 divided by 2 divided by pi, and the answer will be 150,553.78 kilometer. So it will be 1.5 expo 5 kilometer. And if you want the answer in the meters, then you just multiply with 1000. So you will have 1.5 expo 8 meter. So the radius of the orbit of the earth, or the distance between the earth and the sun, is 1.5 expo 8 meter. 1.5 expo 8 meter. I hope you understand this question. Very simple, straightforward question. Okay. Then he says the light emitted by the distant galaxies show various amounts of the redshift. State the name of the galaxy that contains our sun. Our sun is in the Milky Way. The name of our galaxy is Milky Way. Name of our galaxy is Milky Way. Milky Way. Milky Way is the name of our galaxy. Okay. The next question is, state what is meant by the redshift and describe how it is caused. Okay. Redshift, anything which has the wavelength and the frequency, and especially this happens. This is based on Doppler's effect. And O-level students, they have not studied Doppler's effect, but you can we can also make some videos on the Doppler's effect, and I can also tell you right now. You see, if you hear an ambulance approaching you and close your eyes, just listen to the siren of the ambulance. And you know, when the ambulance will come near you, you will observe that the sound of that alarm or that siren, it is becoming shriller and shriller. The reason is, when the ambulance, the source which is producing that wave, is coming near you, the frequency of that wave continuously increases. It is producing the frequency, a sound which has a constant frequency. But because the source is coming towards you, so you receiving the sound waves, their frequency will be more than the frequency which it is producing. So if you close your eyes and the ambulance is approaching you and you hear the siren, the sound will become shriller and shriller and shriller, because the frequency which you are receiving, its frequency is the sound which you are receiving, its frequency gradually increasing. Okay. So another experiment you can do is, you can close your eyes and you can listen to the siren of an ambulance which is going away. And as the ambulance will be going away, the source which is producing those sound waves, it is going away from you. The frequency which you hear, the sound waves which you are receiving, their frequency will decrease. Okay. And this is called Doppler's effect. And when you see, same thing can happen with the light. So if there is a source which is producing the light, and it producing the same light as the light we have on the earth, but if it is moving, for example, it is moving, if it is moving away from us, then its light, when it will reach the earth, the light will, its frequency will be less. And when the frequency of the light will become less, because it's going away, its wavelength will increase. So this is called redshift. And if the thing is the source, and we're talking about stars, we are not talking about bulbs, we're talking about stars, and if that is approaching to you, then the light of that star which you are receiving, if it is coming towards you, its frequency will be gradually increasing. And if its frequency is increasing, its wavelength will be decreasing, and we will say it is doing blue shift. Okay, so the red shift, or we say negative red shift, or we say blue shift. Red shift means that the light which we are receiving from a star or from a galaxy, its frequency has decreased and its wavelength has increased. This shows that galaxy or that star is going away from us. Okay, I hope you have understood. A redshift is an increase in the wavelength and corresponding decrease in the frequency and photon energy of electromagnetic radiation, such as light. This observation can be explained if other galaxies are moving away from us very rapidly. This redshift happens when a galaxy or a star is moving away from us. And this happens, and this can be explained also by the help of the Doppler's effect. Okay, you can search on more videos on the Doppler effect. I have also tried to Explain to you. Milky Way EMF radiation light shifted towards longer wavelength, star galaxies moving away. I hope you understand. Okay, so here we have. Here we have another very important question to see. So he says an astronomer compares the spectrum of the light emitted by the sun with the spectrum of the light emitted by the distant galaxies P and the Q. There are two galaxies P, galaxy Q, and they are comparing them with the light coming from the sun. And in this direction, the wavelength is increasing. So if some pattern is going in this direction, it means it has redshift. Okay. State what figure 10.1 enables the astronomer to deduce about the galaxy P and the galaxy Q. Explain the astronomer's reasons in your answer. Okay. So this portion is here. In P, this portion is little towards the redshift. In Q, it is further towards the redshift. Let's talk about this part of the spectrum in the sun. It's here. The galaxy P is this portion is towards the redshift, and in the galaxy Q, it is further towards the redshift. So it means the Q and P, they both are going away. That's why the spectrums, they are more toward the redshift as compared to the spectrum of the light of the sun. And the galaxy Q is further away from the P. Okay. So Q is faster than the P because Q has larger redshift. Q is further away than the P because redshift increases with the distance. That is the answer. Okay, this is the answer. So, my dear students, we have completed this paper. The paper is over. And so, my dear students, we have completed this specimen paper 2. You see, the last question number 10, we have discussed very in length the answers. Because this is a very brand new topic which is added into the Cambridge Physics 5054, and our students, they have not yet studied them, and you can find literature on this in IGCSE physics book, and my answers are from that book. I wrote the answers from that book. You can also, I advise you to see maximum documentaries, because on the YouTube, you will see documentaries on the space physics and solar system, and that will benefit you. So I have tried my best, and if I have made any mistake, please forgive me. So thank you very much, everyone. If you have liked this video and you have learned from this video, please share the link of this video with your friends, with your class fellows, with your junior students, with your teachers. Share the link of this video onto your Facebook, Instagram, and Twitter accounts. That will help me promote my channel. Thank you very much. Have a good day. God bless you all.